analytically egalitarian agents. It's very easy to develop a division of labor if you have already built into the behavioral assumptions the heterogeneity. Yeah. So instead, start with homogeneity of the agents, but heterogeneity of the pattern, right? That's a more like cooler topic, right, in some sense. And the other thing is to fill in with some more institutional detail, I think. But those are all future research projects, but I thought you did an excellent job.
Thank you very much.
All right, thanks, Peter. Getu? All right, Predrag, I'll start probably with the point I raised earlier about, again, the basis of comparative advantage, which we say productivity, because Peter mentioned again efficiency thing, so I kind of skipped that. And there are a lot of efficiency works. In efficiency work, one of the things we do is we use it actually as for purpose of comparing comparative advantage between farmers and also across regions. So there are a few studies actually. So for example, from Saskatchewan, it's James Nolan, which compared actually farm level different farms in Wisconsin, Ontario, Quebec, and I think New York. And then Peter's work itself is more about comparative advantage, if you think about it, because you're measuring this productivity or efficiency, if you will. And also, Peter mentioned about innovation thing. One of the things actually Grady and I are currently working on is about this clustering. When farms are clustered in a particular area, this spillover in terms of innovation or idea. And so there's now tension there, for example, in terms of environmental externality, and also benefits from those spillovers. So looking at that trade-off is really, really interesting. And that's what I said earlier. There's a rich data to actually look at the individual level, which you claim in your theoretical framework, but you implement in the empirical framework. So that's one thing I really want you to pursue.
Okay, so you would suggest going more into more disaggregated data to do more analysis. Yeah, I would agree. That's also a good point. One thing that I wanted to add is that yes, I agree that there is information that we can gain from cost studies at farm level. What I just want to add is that above and beyond these cost measurements, so average farm or marginal farm cost, there are these other elements of individual knowledge that we can't access through those numbers. And those elements are often, I would, at least in my theoretical framework, would be reflected in some of the quota sales and purchasing decisions. So some of the individual information that is not reflected in those numbers. So that's one of the arguments why quota exchanges offer additional information. So that's in addition, and I agree. Looking at more disaggregated data, even better.
Yeah, when you're talking about the aggregate thing, people will argue as well, the characteristics of individuals are captured in the aggregate. So
yes.
Just like price captured all the information about individuals. So they could argue the same way. That's why they keep using the aggregate model, right?
Yeah,
that's what you're telling me, but
yeah, the reason why it's the aggregate model presupposes certain institutional characteristics that are revealed in the outcomes of this model, right? So what I wanted to start is, let's start with individuals and see the elements of this, or the features of this institutional structure and what it does to reveal these aggregate outcomes, so we can see them actually. So we can't see these aggregate outcomes regardless of the system. For example, as Professor Boettke was talking about the Soviet Union, we just assume a model that functions regardless of what kind of institutional system we have, and we expect the same outcomes. There's an error there because of the individual elements of reality, and then that need to be represented in the model work in a different way depending on the institutional system, and sometimes they don't work at all. So that's the main idea. Start from the from the bottom to better understand how these aggregate observations are generated and what they reflect and what they don't.
Okay, why don't you help me with one question on your estimation? If you go to your table, where you have the estimation.
Maybe I should do this. This one?
I can't see it. Yeah, that table. So you have two time period, right? 1996.
2 points. 2 points in time.
Yeah, 1996 and 2006, right?
Yeah.
So that kind of form, I'll say panel, of the longitudinal data, right?
Yeah, I counted.
Yeah. So if you write the fixed effect model on the whiteboard, so YIT is equal to. I just have a hard time with you. I'm just going to see if you can help me with that. Whatever alpha I plus beta.
Yeah, alpha 0 plus, let's say alpha 1, whatever.
XIT.
1 plus.
XIT, right?
Yeah.
And then you have the usual thing, and then so it says UI and plus EIT coming, right? And then now you take the difference for YIT, right? That's how you estimate it.
Yes. So you mean I take this on the other side, right?
Yeah, it's kind of like fixed effect or what, different is different, right? This is the model you estimated.
Yeah. So I could
change in YIT minus change in YIT minus 1, right? That's what you do.
Yeah. So for example,
it's just there.
Yeah.
Change YIT minus YIT minus.
Yeah,
1,
we
right?
could put it back and see what it does. So it's yeah.
But do you see any problem? So you put back. So you have YIT minus 1. Then on the right hand side. So depending whether you have again the same YIT minus 1.
Okay, so
do you see any problem with that? I don't know. I'm just trying to figure out.
Yeah, I'll write it in same thing, but let's say this is
the Karl population density.
Yeah. So Karl and population density. So we say 2006 minus so it was equal A0 plus A1 times the dummies DI or AI.
Yeah, so that DI is 1996?
Oh, these are just dummies.
No, I mean if you just focus on how density.
Okay, so A equals. So I would start, actually, see this is how I start. I start with this. CD 2006 equals alpha 0 plus alpha, say whatever, alpha 1 times CD 1996.
Okay.
Then I take this to this side. CD 2006 minus, let's see, alpha 1 CD. Is it okay?
So Predrag, you have two equations, right? One equation is for 1996, another equation is for 2006. Take the difference of the two.
Yeah.
Now my problem is, why do you have a lag of curve of intensity? Because is that going to create some issue? Is that going to be correlated with your error term? If that's the case, what is the implication of that?
Okay.
And by construction, I would expect always that's going to be significant.
I see what you mean. Yeah. So, yeah, that's what yeah. Okay. So I had now, yeah, this was the alpha 1 times 1996. So what we can do here, sorry, I'm just going to do these steps. Is that okay?
Yeah.
Okay. So alpha 0 plus alpha 1 times 1996 plus CD 1996. So what I get is CD 2006. So that's the same thing, just in a different form. Alpha 0, and then I can put CD 1996, and I can have alpha 1 plus 1 here. So this is now the coefficient for this regression. So basically, whatever this beta 1. So how this would look like is, if we had 1996 density on this axis and 2006 on this axis, so we would have some alpha 0 here. So CD, so this is CD 2006, CD 1996. So this would be alpha 0, and then we would have this alpha 1 plus 1, so that would be the slope, whatever the slope would be. So we would be looking, so this regression is a form of this regression. So if alpha 1 was 0, then this would be just CD 2006 equals CD 1996 plus alpha 0, so it would be just a parallel shift there. So I derive this regression from going from here.
But if you follow the fixed effect model, where you have two time periods,
Okay.
how you have change in the curve density,
Okay.
and then that equals to change on whatever variables you have on the right hand side.
Yeah.
That's all I do. But what you have is you have change in curve density, the function of the log curve density.
No.
And my worry is what is that is number one, correlated with the error term. What does that lead to? Number two, by construction, I would always expect those variables are going to be negatively related. So will there be a better or kind of ideal measure, different measure to capture the environmental pressure other than just doing the lag of your, I don't know how to call it, but the difference variable. So like a couple of issues there. Number one, by construction, I would expect that's going to be negative. There will be negative relationship between those two. And the other thing is, I'm worried about possibility of correlation between the error term and that lag variable. So if you just elaborate on those two.
So you are concerned that by construction there will be negative correlation between initial curve density and the change in the curve density. So that we would, from the outset, expect that counties with higher curve density would experience higher declines or lower increases in curve density between the two years, given the regression. Now I would have to go and check more